Have you ever pondered about the possibility of Earth having more than one moon? I'm Dr. Nova Starlight, and I will shed light on the fascinating topic of quasi-moons. It turns out, our Earth secretly boasts more moons than it reveals on its celestial tax return. But these covert satellites abide by a different set of rules. They're not the typical large, round objects we've all sketched in our classwork, forever ensnared in Earth's gravitational pull. Quite the contrary. These are asteroids entangled in a universal tug-of-war between the unyielding attraction of Earth and the radiant appeal of the Sun. They're the uninvited guests at our cosmic gala, appearing out of the blue, hanging around, and then embarking on their next escapade. Now, allow me to introduce a few of these infamous freeloading rocks. Make acquaintance with 3,753 Kruthna, frequently dubbed as Earth's auxiliary moon, and then greet 2020 CD3, a car-sized celestial sensation that tagged along with us for a brief joyride in 2020. Isn't it oddly reassuring to realize we've got these surprising cosmic allies on our regular orbit around the Sun? As I surely will agree, space never fails to surprise us. Let's imagine for a minute that you've just run into our special guest, a jovial astronaut named Buzz Stronaut, in a cosmic cafe. Buzz, with his usual humor, strikes up a conversation. Ever wonder, my friend, how these quasi-moons manage to stick with us in our orbit? He chuckles at his own pun, then gets serious as he leads us into the intriguing world of orbital mechanics. You see, quasi-moons are funny things. Despite their name, they aren't quite moons in the traditional sense. Buzz points out, they're like that distant cousin who shows up at family reunions. They share our orbit around the Sun, but they don't exactly orbit Earth like our dear moon does. He sketches in the air with his fingers, painting a picture of Earth and these quasi-moons in a grand cosmic waltz, circling the Sun together. But it's no easy two-step, he warns. These quasi-moons are like quirky dance partners, weaving an intricate path, looping around Earth, darting ahead, then falling behind, only to loop around again. Buzz describes it as a cosmic game of tag, where the quasi-moon and Earth are constantly chasing each other, but never quite catching up. This cosmic tango, as Buzz calls it, can continue for hundreds, even thousands of years. How is it possible? Well, as Buzz explains with a wink, it's a delicate equilibrium of forces. You need the right speed, distance, and a pinch of gravitational pull, the ingredients for a perfect cosmic cocktail. But Buzz warns, this dance isn't always eternal. Sometimes a quasi-moon can lose its balance and it's swiftly replaced by another. As Buzz leads us through this celestial spectacle, he leaves us with a bit of astronaut wisdom. Our Earth is leading a cosmic ballet with these quasi-moons. Isn't that just a stellar performance? How do we even find these elusive celestial dances? It's a question that's been baffling astronomers for decades. Let's take a journey back in time to the discovery of the first quasi-moon, 3,753 Kruthni. This intriguing object was first spotted in 1986, but at the time, it was simply classified as an ordinary asteroid. It wasn't until a decade later that scientists began to notice something peculiar about its orbit. Using advanced telescopes and orbital simulations, astronomers discovered that 3,753 Kruthni was not just another asteroid, but a quasi-moon. Its unique horseshoe-shaped orbit around the Earth set it apart from the usual celestial bodies. It was a groundbreaking discovery that opened the door to the possibility of other quasi-moons lurking in our cosmic backyard. Now, fast forward to the 21st century. Advanced astronomical tools have become even more sophisticated, allowing us to peer deeper into the cosmos than ever before. In 2020, a car-sized object known as 2020 CD3 was spotted. This tiny traveler was temporarily captured by Earth's gravity, becoming a mini quasi-moon for a brief period before continuing its journey through the cosmos. The discovery of 2020 CD3 was a testament to the power of modern astronomical technology. It was identified by the Catalina Sky Survey, a program designed to detect near-Earth objects that could potentially pose a threat to our planet. It was a chance find, a cosmic gem hidden among the stars. But how do we find these tiny, elusive objects? It's all about patience, precision, and a bit of cosmic luck. Astronomers use advanced telescopes to scan the skies, meticulously investigating any object that seems out of the ordinary. Orbital simulations then help to determine whether these objects are indeed quasi-moons, based on their unique movement patterns. Finding a quasi-moon is like finding a needle in the cosmic haystack, but with the right tools, we keep uncovering these hidden gems. Our journey into the cosmos continues, and who knows what other celestial surprises await us in the vast expanse of space. Why should we care about these tiny, distant objects, you may ask? Well, it's not just about their fascinating dance around our planet, but the scientific significance they hold. Quasi-moons, as small and distant as they may be, provide us with intriguing insights into the early solar system and the formation of planets. Let's take a trip back in time about 4.5 billion years ago, when our solar system was just taking shape. Imagine a swirling disk of gas and dust. Over time, these particles started to stick together, forming larger and larger clumps. Eventually, these clumps grew into the planets and moons we know today. Now, studying quasi-moons can help us understand this process. They're like little time capsules, preserving the conditions of the early solar system. But the significance of quasi-moons isn't confined to the past. They also have potential implications for our future. In the realm of space exploration, these objects could serve as stepping stones for future missions. With their low gravity, landing on and launching from these bodies would require less energy than a trip back and forth from the Moon or Mars. And let's not forget about resource mining. We're still in the early stages of understanding what quasi-moons are made of, but it's possible they could contain valuable resources. Imagine mining operations on these tiny moons, extracting materials for use in space construction or even as a source of fuel. In essence, quasi-moons are more than just celestial oddities performing a cosmic ballet around our planet. They serve as a bridge to our past, a tool for our present, and a potential resource for our future. These quasi-moons are not just celestial curiosities. They hold the keys to unraveling the mysteries of our solar system and beyond. Until next time, keep looking up at the stars